Welcome back, guys. We'll solve the 1100 rated question now. So the question says that you are given an array. An array is a palindrome if b of I is equal to b of m. What is b of m? The size of the array. b of m plus 1 minus I. So this is just a palindrome in mathematical terms. So palindrome is if the first ith element is the same as from L minus I, right? So an empty array is also a palindrome, and a Kalindrome is a Kalindrome if the following condition holds: that it is possible to select some integer and delete some elements of that array which is equal to that integer x, so the remaining array is still a palindrome. Okay, sorry, the original array is a random array, it is not a palindrome. We'll delete some occurrences of the integer x and the array becomes palindrome. If this is correct, then it is a Kalindrome array. For example, we'll take the example as this should print yes. So if we delete the number 4s, all the number 4s, or either if we delete all the number 1s, the remaining array is a palindrome. Therefore the original array is a Kalindrome. So okay, let's see what the given question is. That there is some array, and from this array we delete some instances of the integer x, some x. Okay, and it is also given that note that you do not have to delete all the elements, and you also don't have to delete at least one element. From this it means that we can delete any number of x, right? We can delete from 0 till all the instances, till all. We can either delete 0 of these instances or all of the instances of x present in this array, and after deletion the remaining array should be a palindrome. If that is correct, then the original array was a Kalindrome. So let's write it in a mathematical terms, or in the form of an array. So a1, let's say a1, a2, a3. Okay, instead of the indices, we'll directly write the elements. Like if it was a, b, c, d, and we'll create a palindrome d, c, b, a. This is a palindrome, and we'll add some instances of x, which makes it not a palindrome. So let's say x, and we add an x here. So as you can see, this whole array is not a palindrome. This is just a given array. Now we need to select an integer, and after deleting some instances of that integer, we'll get a palindrome as the resulting array. So in this case, if we delete this element, the array becomes a, x, b, c, d, d, c, b, x, a, which is a palindrome, right? Yes, it is a palindrome. So that is what we have to do, that after deletion the array should be a palindrome, right? And you can also observe that here I have deleted just one instance of x, and it becomes a palindrome. But if we delete all the instances of x, that means we delete this and this too, that is, we erase this x and this x also, still the resulting array is a palindrome. Okay, so instead of deleting some, as in the question it is given that you can delete some integers of some instances of x, right? From none instance to all the instances. To make our life simpler, to make it easier, because we don't have to worry which index we should choose, we'll say that we'll delete all the instances of x, because that makes the question easier, because we don't have to worry where the x should be, and it doesn't change the question also, because even if we didn't delete those x, it would still have been palindrome, and even if we delete that x, it is still a palindrome. So the question remains the same, but we just made our lives a bit easier, that after saying that we'll delete all the instances of a particular integer x. Now how will we proceed? Let's try reverse engineering. Okay, I'll use a fancy word. Let's reverse engineer this. that from a palindrome there will be some x added at some positions, and that will give us the resulting array, right? That is the reverse of the question. So can you find the approach? That we are taking a palindrome number and then we are adding x to it, so x was here, right? So x and x, so these are the numbers we have added. I'll mark them in different color. These are the x we have added. So from a palindrome we have added x, right? So that is that we are taking a palindrome and we are changing it. And how we are changing it? That we are adding a single element. We are adding a single value of an integer. We are adding only x. The value x is added multiple times. It can be 0 number of times or it can be a lot of number of times, right? So how can we proceed this? Let's say if we are given an array, I'll just take a general case. So we will be given an array, and we, for a palindrome, it may be that the original array itself is a palindrome, right? So we'll say that, let's say it was an palindrome originally. So what will be the condition? That all the first element, let's say it was a, will be equal to the last element. So this will be a. The second element will be equal to the last second element, b. The third element will be equal to the last third element, c. Now let's say we come across that integer x, which after removing that integer the array becomes a palindrome. Let's say we come across this, right, an integer x. So after removing this x, the array becomes palindrome. But how will we know that we have come across such an element? We'll know because that will not be equal, right? If it was x present at the fourth place, from the last fourth place there will be a different element here. So after removing this is an array, okay? So after removing this x element, the resulting array will be beautiful. So the fourth position will be d and the fourth will be from the last fourth, that is d. So it is a palindrome. But how did we know that we have come across, when we are iterating through the array, how did we know that we have come across such an element x that we have to delete it? It will be because that element will not be equal. It will not be equal to the last fourth element. So the fourth element will not be equal to the last fourth element. So now we know that we have to delete this element. Okay. Similarly, this can also be the case. Okay, just its opposite. As we were iterating from left to right, and we came across that element x at the left hand side of the comparison, right? So it can be that we come across it at the right hand side. So a, b, c, c. Now let's say we come across x from the right. There is an x present here. How will we know this, that we have come across such an x? It will be because this element, the fourth element, will not be equal to the first four. This will be d here. There will be some other element here. Then it will be d here, and let's say e. So after deleting this x, the resulting array is a, b, c, d, e, d, c, b, a, which is a palindrome. So that is the condition. We'll iterate through the array, and when we come across an element which does not come equal, we'll note that there is a possibility that this is the integer, the one which is not equal. After deleting that element, the resulting array becomes palindrome. And due to the, as we stated up here, if we remove all the instances of x, that is the same as removing some instances of x. So to make our lives easier, we'll directly remove all the instances of x. So that is what the code is. I'll show you the code, the implementation. Just a second. I have not reloaded the page. So we'll iterate through the array and find all the equal pairs, and okay, the net is gone. Just a minute, guys. I'll show you here. So this is the solution. This is a function I created which takes an array. Okay, I'll explain it from the main. So we take the input in an array list. I'll tell you why later, because we need to remove the element, right? What is our approach? That will iterate through the loop, and once we find the elements with element I which is not equal to element at equal n minus I, then we'll remove that element and check if it is a palindrome. So we are removing that element, right? So and checking for the remaining array. If it was array, we will have to do the shifting, but if we do an array list, then there is no need of shifting. We can directly remove all the instances and the remaining array is automatically compacted itself. Okay, so I take it in the form of an array list, and I take all the inputs and I iterate from I is equal to 0 till the half of the array, because what am I checking? If the ith position is equal, the value at ith position is equal to the value at n minus I minus 1, that means the first ith element should be equal to the last element at the ith position from the last. And as this is an array list of integer objects, not the integer primitive data type, this is a secondary data type, right? Integer, this is the object, so we need to use dot equals. We can't do directly if a dot get I is not equal to a dot get n minus I minus 1. We need to use this function because this is an object. So integer objects will use the equals function. So if we find that such a index that the value at this index is not equal to the value at that index from the end, then that means there is a possibility that we have found x. What will be x? X will be either be this element or this element, right? Either of this element it can be. So we'll create two new integer list, array lists, right? Two new array lists. Array list 1 will be the array list when we remove all the elements x, and x is what? X is, we have considered that x be the element at position I. In the second case, it will be the element at the position n minus I minus 1, and that is the function I have created. This r is the removal function. So this removal function takes an array list and also an integer x and removes all what is this? Collections dot singleton. This creates an array list with only x as its element and removes all that. On comparing the array list B with the array list of all individual x, it will remove all the ones which are same. So it will remove all the x, right? This is the function of this singleton object, right? So it will take an array list and an integer x, and it will remove all the instances of this integer x from this array list. And we don't need to modify the array list A itself. So we are not performing the operations on A itself. We are creating a new temporary array list B, and we are changing that B and returning that B array list. Okay, we are making a copy and returning that copy. So the returned element will be the array A, excluding if we consider x as the ith element which was not equal, and the other case was it will be the ith element from the last, because in inequality, right? Just a second. Right. In this inequality here, d is not equal to x, right? The ith element from the beginning, the fourth element from the beginning is not equal to the fourth element from the last, right? So d is not equal to x. In here I have shown you that x is towards the right hand side, but for the computer it doesn't know, right? So it needs to check that by considering both of these values as x. So if this could be x and if this could be x, the element d could be x and the element from the end is x. Okay, it checks both the possibilities, the code which I have written. So I check both the possibilities by creating two different array lists, one considering the first ith element as x and second considering the last ith element as x. And after creating those array lists, I check if the remaining this is the array list of the remaining values, right? So if the array list is palindrome and here if it is not palindrome, I have set the boolean flag as true initially, and if both of them are not palindromes, I change it to false, else yes will be the answer and it will print as it is a palindrome. So I have taken the negation case. Okay, and this is the palindrome function. This is quite simple. I iterate through the array similarly from index 0 till half of the array, and check if here also it is an array list of integer objects, not the data types, right, the primitive data type. So we need to use dot equals functions, not directly equal to sign, right? I hope you understand that. So this was it. We check if the resulting array list is palindrome, and if either of them is palindrome, that means yes, there is a possibility where x we have considered is true and the remaining array is a palindrome. So this was the code and that was the logic. I hope you guys understood my approach. Thank you guys.